Okay, I think we're going to get started. Hello, everybody. My name is Steve. I am going to be your GRE/GMAT instructor for today. What we're going to be doing today is talking about some of the more difficult word problems and kind of approaches to getting through them. Word problems tend to be the bane of a lot of people's existence on the GRE and the GMAT and other standardized tests. So what you want to do is figure out a way in which you can basically sort of reduce these complicated problems to something that makes sense. You want to be able to extract the important information. So what I'm going to do is share the screen to start out. Let's make sure things are recording. Yes, things are good. Okay. Give me a second to share. Okay, translating from English to math and difficult word problems. The first thing I'm going to do is lay out some kind of general strategies. When you're dealing with quantitative problems, there's kind of a certain way that you want to go about them. All right. You basically want to have a pretty rigorous strategic approach. You don't want to go into these things blindly. Right. And what that means, you want to basically find a way to put yourself in the mind of the people who actually write these things, of the test writers. All right. Because the thing is, there are not going to be all that many concepts that you're actually being tested on. Right. Maybe there will be 100 or something like that. And you're already going to be familiar with the vast majority of them. Right. You know how to count. You know how to multiply. You know how to do basic algebra. You're going to know, the vast majority of what's going to be on there. What's tricky is figuring out when and how they're actually asking certain things. All right. So, what you want to do is basically have a good kind of comprehensive strategy in order to do this. So in general, we've talked about this a little bit in other sessions before, but I'm going to, kind of lay this out in kind of general terms. First thing, you always want to make sure that you're reading the question carefully. All right. Put a little bit more time in at the front just to kind of make sure that you know what's actually being asked. All right. Read the question and identify what is being asked. All right. It's very easy to get caught up in, in say solving for 3A, and then when they ask you for B, you spent all your time solving for something else, so you aren't actually responding to the question, right? Or if there's a word problem and it says like, how long does something take, right? Well, they're going to be asking for some unit of time, maybe hours, maybe minutes, right? So don't give them, something that they're not looking for. All right. Identify what's being asked. Identify the concept. You need to identify really quickly what kind of things you're being tested on, right? And some of them are going to be obvious, right? If you've got, say, a problem with square roots or a problem with exponents or something like that, it's going to be pretty obvious what's being asked. But it may not be as obvious when you're dealing with word problems, right? Because you've got a first step to translate English to math in order to actually work with the problem. All right. So you want to identify the concept and know how to simplify and translate. If you've got a complex algebraic expression, see if you can whittle it down to something that makes sense. If you've got, say, a whole paragraph full of text, see if you can extract, the key important data. Let's actually put that first. Extract key terms, important data. Say important data or quantities. All right. Know how to simplify and translate. Number 5. Look for clues within the question and answer. That's going to help guide you, all right? And then determine a set of strategies. Now that you know the concepts are being tested, you want to figure out, well, okay, what strategies can I use? Am I going to, use straight algebra? Maybe try out your own numbers. Work backwards from answer choices. Are you going to draw something? I find that drawing and visualizing is something that is really overlooked. And I think that if you just kind of draw things out, it'll help a lot. All right. Okay. And then obviously do the problem. Now, this is really kind of the same for most problems, whether word problems or not. Kind of the added layer with word problems is that you're dealing with something a little bit different. You're dealing with a textual, representation of abstract concepts. So there's another layer. You need to say, well, okay, what kind of, fundamental concepts am I actually being tested on, right? So hold on one second. Hi there, somebody just saw that you showed up here. Okay. Okay, so let's go and take a look at some actual problems. All right, we're going to be focusing on both the GRE and the GMAT. The problem-solving aspect of each is going to be quite similar. On the GRE, you've got your quantitative comparisons, right, where you want to figure out whether quantity A is bigger, quantity B. Whereas on the GMAT, it's a little bit different. You've got data sufficiency type of questions. All right, so let's go and take a look. Where are we going to start out? Let's start out with this. And keep in mind, we're going to be focusing on difficult problems today. All right, these are not going to be, these are the ones that are going to be 650 or above, even 700 level questions on the GMAT, and probably, let's say, 160 or above to on the GRE. So let's take a look at the first one, and I'm actually going to give some answer choices here. So let's see. Let's say A, let's go with 10, B, let's go with 12, C, 28, D, 40, and E, 50. All right. Okay, so 1 second. Let's take a look here. All right. I'm going to give everybody, maybe let's say 30 seconds to take a look at this question. And one thing I didn't mention in the strategy is it's a good idea to determine as you're going through the initial read of the problem, how difficult you feel that the problem is going to be. If it's too hard, or if it's something that you feel is going to take you 6 or 7 minutes, then you're going to need to move on. On the GRE, you have the option of flagging the question, taking your best guess, and coming back to it. On the GMAT, you don't. But keep in mind that in both of those exams, you can do extremely well while missing a lot of questions. All right. So we've got something here that is very text heavy. It's not the longest paragraph, but it's definitely all words, right? There's no mathematical expressions here. All right. It's a tough question. So applying the strategy, breaking down the word problem, what do we need? Well, first of all, you're going to read the question, which you've done. All right. What's being asked? Okay. What are the concepts? Well, clearly, average is going to be a concept, right? Arithmetic mean, that's about averages. And remember, when you're dealing with averages, you may want to deal with the total, right? Because the average is the sum of the terms divided by the number of terms, right? So for many average questions, it might help you to get the total somehow. Okay, what else do we have? The average is 10. That gives us some information. Then what do they want? They're asking for a difference between the largest value of the greatest integer and the least value of the greatest integer. The wording in this problem is not great, but you're going to find that the wording is sometimes not all that, clear. So what you need to do is take a little bit of time to break it down. Okay, so they're looking for a difference. That's key, all right? Between the largest, a maximum, the largest possible value of the greatest integer, largest top number, right, and smallest top number. All right. Okay. So what I would recommend for this kind of thing is a couple of things first. Keep in mind the basic concepts. When you're dealing with an average question, it's probably going to help you to get the totals, right? So if you have 5 numbers with an average of 10, that total is going to be 50, right? Because you got the number of terms times the average of the terms can equal your total. All right, so we're going to have numbers that are going to total 50. Okay, great. Okay, now what do we want? How are we going to figure out the greatest possible value of the 5 integers? Well, this is really a maximum minimum problem. When you're dealing with average problems, very often they're going to be in the context of maximizing or minimizing something, right? So if you want to find the largest possible number, you want to minimize everything else, right? Find largest possible number, minimize everything else. And vice versa, right? So to find the smallest possible number, you want to maximize the others. Okay. So let's start out. Okay, so how are we going to find the largest possible number? Well, okay, it says that the numbers are distinct, right? The numbers are different. Okay. So, and they're different, they're integers, they're all positive. So we know that at least one of those numbers, the lowest one's going to be 1, right? Okay. Because they're distinct, we can't have all 1, so the next one's going to have to be 2. The next one's going to have to be 3, and the next one's going to have to be 4, right? That gives us a total of 10, right? Which is going to leave 40 over here. So the greatest possible number, oops. Okay, so the greatest possible number is going to have to be 40. All right, so we've minimized everything else, and we've maximized this. Now the second part's a little bit trickier. The least possible value of the greatest of the 5 integers. Okay, so we're looking for a low value on the high side. All right. So here's the thing. If we assume that all of the numbers, when you're dealing with average problems, it can be useful to assume that everything is the same and then find a point of departure, right? So if we assume that everything was 10, that would fit the criteria, right? You'd have 5 numbers, total is 50, the average is 10, all right? If we're trying to find the lowest possible number on the high side, well, the thing is that we can't have all the numbers lower than 10 because that would mean that the average itself would be lower than 10. So we're going to need to have some numbers that are below 10 and some numbers that are above 10, unless they were all 10, right? But it tells us that they're distinct. So we could imagine then, because they're all integers, well, what happened if we lower 1 to 9? If we did that, then we'd have to balance it out with an 11. That gives us 2 left over. Again, they're all integers and we can't duplicate. So the next one down has got to be 8, meaning that the next one to balance it out is going to be 12. All right. So the lowest possible number, the lowest possible greatest number here is going to have to be 12. All right. If you add these all up, again, you get 50. The average would be 10. So the difference between 40 and 12 is 28. All right, tough problem. It's one of the harder ones you'll come across. Any questions on that one? If not, then we will move to another one. Okay. Let's move on to another type. This is another GRE one. This is a hard problem. This particular problem shows up quite often in challenging GRE problems. Excuse me. Okay, so I'll let you guys give yourselves, I don't know, maybe about 30, 40 seconds to read it. See if you can figure out kind of what it's actually asking. Okay. Actually, maybe another 10 or 15 seconds because this one's pretty involved. Okay, so we have what's clearly a number theory problem, but it's a word problem, right? Okay, and we have a lot of things that they throw in to make it more difficult than it might otherwise be. All right, how are they doing that? Well, one thing that they're doing, they're giving us a lot of variables, right? They're giving us a letter S, they're giving us an n squared, they're giving us n. First thing is S is just, we don't need S. S is just talking about, they're calling those numbers S just because of convention. But we're not actually doing it for any math, all right? Then we want to figure out what's being asked and what are the core concepts. Well, okay, they want to know which of the following integers are divisors of every integer. All right. Another more comfortable way of saying that might be factors. You're familiar with factors and multiples. You're probably familiar with divisors as well, but you're not going to see that term as often, right? So you want to reduce the terminology into something that makes sense. Okay, which of these integers are factors of all the integers n in that set? Okay, now what do we need? And we want to figure out, can we figure out what concepts are being are being tested here? Well, we've got multiples and factors. Very often when you're dealing with factor and multiple type of questions, you might be dealing with prime factorization. You might be dealing with least common multiples, greatest common factors, those kinds of things. All right, this is clearly a factor multiple question, which means you might be dealing with things like factor trees. So the first thing I would say, okay, we're looking for a common multiple of 24 and 108. But we're not just looking for any common multiple of 24 and 108. We're looking for a common multiple of 24 and 108 that n squared could be a multiple of. All right, so we're looking for a multiple of 24 and 108 that is also a perfect square. All right, let's write that down. We need a multiple of 24 and 108 that is also a perfect square. All right, if we didn't have that n squared thing in there, we wouldn't need it. But this is saying that we can't just use any multiple. So how are you? All right, what's kind of the approach to figuring out multiples of large numbers? Well, one thing you can do is a factor tree, right? Remember that whole 24 is 8 times 3, right? That's 2 cubed times 3. 108 is a little bit more involved. It's going to be 12 times 9. Say 3 squared times 12. 12 is 2 squared times 3, right? Okay, so 24, we have 2 cubed times 3. And 108, we have 2 squared times 3 cubed. Okay, the first step is to remember, how do we get common multiples? The least common multiple is going to be the highest degree of each of those prime factors, right? So we're going to need to have at least 3 factors of 2, and we're going to need to have at least 3 factors of 3. All right? Because 2 squared goes into 2 cubed, so we don't need any more than that. We just need to make sure that we've got the highest one. So the least common multiple of both of those numbers would be 2 cubed times 3 cubed, whatever that is. And again, we don't need to know because we're dealing with high numbers, right? So we're not actually being tested on the numbers themselves. We're really being tested on the factors. Okay, 2 cubed times 3 cubed is going to be our LCM, our least common multiple, right? It's going to be 27 times 8, whatever that is. Okay, now here's a problem. 2 cubed times 3 cubed is not a perfect square. How do we know that 2 cubed times 3 cubed is not a perfect square? Because we don't have an even exponent here, right? You can't easily take a square root of 2 to the 3rd power, right? Because what's a square root of 8? Square root of 8 is going to be, like 2.6 or 2.7 or something like that, right? You can't take the square root of 27 either. If you want to have a perfect square, you're going to need to have an even exponent, right? So because we're looking for, again, how do we know that we need the perfect square? Because it's asking us, it's saying that n squared is a multiple of this, all right? So we're going to need to multiply by another 2 and another 3. So the least common multiple that is also going to be, you know, a perfect square is going to be 2 to the 4th times 3 to the 4th. That's the least common multiple. It's also a perfect square. All right. Okay, so now it's saying, well, that's n squared. So what's n going to be? Well, n is simply going to be the square root of that. So the square root of that is going to be 2 squared, or the least possible value of n is going to be 2 squared times 3 squared. That's easy to figure out. That's simply 4 times 9, which is 36. All right. So what we are simply asking then is, what are the factors of 36? And there are 2 of them. There's 12 and there's 36. That is a hard problem. That is absolutely like a 165 plus level problem in the GRE. If you saw it in the GMAT, it would be in the 700 levels. All right, not an easy one. Okay, let's take a look at some other ones. See how we're doing on time here. Okay, we've got time for a few more. Okay, for those of you who are taking the GMAT, let's take a look at a data sufficiency type of question. Now, remember what you're doing with data sufficiency questions on the GMAT, right? So the GMAT data sufficiency, excuse me. What they're asking you is, do we have enough data, right? Okay, so your, basically your answer choices are A, statement 1 is sufficient. B, statement 2 is sufficient. C, both statements together sufficient. D, either statement 1 or statement 2 alone are sufficient. And E, either statement is sufficient, meaning that you don't have enough information, even if you use it together. All right. Okay. Let's take a look. What do we got here? Yeah, I'll give you maybe say 20 seconds to get through this one. Let's say again, you want to identify the core concept. Core concept here is obviously going to be median, right? And for this kind of thing, it can be very useful to draw things out. All right. What have we got? We've got X, shelf X, and shelf Y. Let's draw it out kind of in a line like this, because all right, now we've got 25 here. We've got 25 there. The median thickness, what does that mean? It's going to be the middle number, right? Or in the case of an even number of terms, as in 50, it's going to be the average of the middle 2 terms, right? So it's going to be, the median is going to be, this is book number 25, and this is book number 26, it's going to be the median of an M in there. It's going to be in the middle there, right? Okay, so now we're trying to figure out, what else do we know? Oh, well, everything on book X, on shelf X, is thinner, right? So all the X stuff is thinner than Y. We don't have anything that's equal. We don't have anything that's greater, okay? So what do we know? Statement 1, The thinnest book on X is 2 millimeters thick. That's all well and good, but that says absolutely nothing about anything else. These books could go up to could go up to phone books, right? We have no idea. That is simply not going to be enough. So you're going to rule that out, right? You're also going to rule this out, right? Because if statement A is not enough, then clearly statement A or B alone is not going to be sufficient either. Okay. What about statement 2? If the thinnest book on Y is 20 millimeters thick, and we want to know if the median is less, okay? Well, the thinnest book here is going to be 20. Now, here's the thing. It says that everything on book X is less than that, right? So we can't have a 20 millimeter book on X. We're going to get stuck at like, maybe 19 or 19 and a half or whatever, right? It's going to be something less than 20. Call it 19.5, whatever it is. Even if it's 19.999, it's got to be less than 20. That's going to give us enough information right there, because the median of those two, it can't possibly be 20. It has to be less, right? The only way the median could be equal would be if the largest book on shelf X were 20, but that's impossible because it says all of the books on shelf X are thinner. So because of that, statement 2 is the right answer. All right. So again, for word problems, identifying the concept, drawing things out can be extremely useful. Okay. Okay, let's move on. Excuse me. Allergy season here. Do a couple more of these. Here's one. It's a rate time distance problem. This is a GRE quantitative comparison type. So essentially what you're doing, let's write those out. So for these in the GRE, so A would be quantity A is greater, B, quantity B is greater, C, the quantities are equal, and D is cannot be determined from information provided. Okay. Again, keep in mind how these are a little bit different. So here with the GRE, you're basically comparing values, whereas with the GMAT, you're determining whether the values are enough to give you the answer to the problem. All right. So sort of along the same lines, but kind of a different logic. Okay. Okay, why don't you guys take a little bit of time? I think this is probably, let's see. Yeah, maybe we'll do one more. Okay. Again, give yourself 20, 30 seconds. Okay, from a concept perspective, well, clearly we are being asked, it's a rate time distance problem, all right? Rate time distance problems often lend themselves well to either drawing a table or drawing a diagram. I personally like diagrams. I know that, some people like tables, all right? Whatever works for you. Okay, so what's going on then? What do we need? Let's see, what are we looking for? Well, here, we're looking for total time, right? Okay, but we're changing some variables, because here we're total time. Here, if the times are equal, say t equals t, right? And here, if the distances are equal, if the distance equals distance. Okay, so what do we got? If we're going to take the diagram approach, let's draw it out. So here's Robert. Here's a 120-mile trip. The first part, actually, before I do that, remember the remember what the equations are, right? It's like we're talking about rate times time equals distance. But the way that rate time distance problems are made more difficult in both the GRE and the GMAT is they will often, the rates or the times and the distances may not always be the same, right? You may have a couple of different people traveling. You may have different starting points. You may have different people might be leaving at different times. So they're basically taking ways of modifying your basic rate times distance equation and introducing more variables, right? So you might have rate time distance for the first person, rate time distance for the second person. In this case, we have a couple of different legs for the trip, right? So we only have one person. We've got Robert. We call him R. But there's two different legs to the trip. Okay. Now remember, whenever you see distance, you can think of it as rate times time. Okay. So what do we know? Well, his rate, let's say here's the first rate times time. Here's the second rate times time. Keeping in mind the rate and times may not be the same. Okay, so what do we know? The first part is 20 miles per hour. 20 times, call it T1 for the first leg. Second part, 30 miles per hour times T2. Each of those is going to give us the first part of the distance, and that one's going to give us the second part of the distance. Okay, so now we're trying to figure out, okay, let's look at quantity A first. Let's say he took an equal amount of time at each speed. Equal amount of time, what does that tell you? It means that you only have one variable for time. You don't have two, all right? Which makes life easier, all right? So we don't have a couple of variables you have to deal with. So essentially what's going on then is you're going to have your rate times time, which is going to be 20t, plus 30t. Remember, the times are the same in this case, will equal 120. The first leg plus the second leg equals the entire distance. So 50t equals 120. Or your time equals 12/5. Okay, so it took Robert 12 over 5, whatever, hours, right? 2 hours and whatever, 24 minutes to take the first leg of the trip. Okay, what about the second part? Here we've got an equal distance. Okay, if the distance is equal, right, then that means that there's going to be that leg 1 and leg 2 are going to separate at the halfway point, which means that it's going to be 60 miles for each one. 60 miles for the first leg, 60 miles for the second leg. Okay, so what's the time going to be? Well, okay, now the times are going to be different. So 20t equals 60 for the first leg. And for the second leg, it's going to be 30t equals 60. Which means it's going to take them 3 hours for the first leg, 2 hours for the second leg. 3 plus 2 equals 5. All right. So this is going to be 12/5. This is going to be 5. Therefore, quantity B is going to be larger. All right. Okay, I think we're going to close out with a geometry problem. This is going to be a tough one. Hold on one second. Okay, I'm not actually going to include any answer choices here. This is really just, to kind of show how the, how the approach can be applied to geometry questions too. So keep in mind the word problems, they're not just for algebra, although you definitely see them, you see them with a lot of algebra problems, but they can definitely, fit with geometry problems as well. All right. Take some time with this because this is obviously going to involve, some drawing to make sure you're kind of conceptualizing what this thing's actually asking. And one thing that I should probably, you're not going to be given this on the test, so, 1 second. So the volume of a sphere is 4/3 pi r cubed. You really should know the volume of a cylinder, but you don't need to know the volume of a sphere. But just in case, I'll give you the volume of a cylinder as well. So volume of a cylinder is pi r squared times the height. Okay. Now, some things to keep in mind when you're dealing with GRE and GMAT questions is if they're giving you large or difficult quantities, there might be something to, they might have certain characteristics, right? Because this is not a computationally heavy exam, right? It's meant to identify concepts, not do annoying math, right? So if they're giving you numbers like 50 or 260, there might be a reason for them, all right? So let's start to draw what this thing actually looks like. Okay, we have a sphere. Let's draw our sphere. Pretend that's a sphere. Okay. It's got a radius of, let's see, so let's draw the cylinder. It's inscribed, right? Remember what inscribed means? So it's actually, touching the, the other object. My drawings are not very good, but that's generally get the point across. Okay. Now, that cylindrical can has a radius of 50. All right, so let's see what to do with this. Radius is 50. Okay, so that pretty much covers, oh, okay, then the, whatever you call it, the whole sphere there, that's a diameter of 260. This is in general, this is kind of broadly the way that most people generally draw this thing out. Okay, now, remember what I said, it's very important to take time to read the question and figure out what it's asking. What's the volume of the region not taken up by the cylinder? That's basically a shaded region problem, right? I haven't actually shaded it, but it's that kind of thing. If we were to go like that, right? So how do you do shaded region problems? It's always going to be, one object minus another object, right? Area or volume of shaded region, right? It's going to be volume of cylinder or sphere minus volume of the cylinder. Okay. Now the volume of the sphere is not difficult, right? Because I'm giving you the equation right there. All we need to get is a radius, and you have the diameter, right? So the volume of the sphere is simply going to be 4/3 pi times half of that, right? The radius, which is going to be 130 to the third power. All right. Now these numbers are large, meaning that you're not going to need to actually calculate them or anything like that. Just kind of, you'll leave this as is. Okay, now we need to figure out the volume of the cylinder, which is harder. So what's the problem here? Well, we know that it's going to be pi r squared height, and we know the radius is 50, so that part's easy. So, 2,500 pi times height. Problem is, how do we figure out the height? So you'll say, well, okay, we've got a diameter, but that diameter, going from here to here tells us absolutely nothing about the height of the cylinder, right? So here's where you want to be a little bit creative, and you want to see, kind of what information is given that you might be missing. And what's missing here is that 50 and 260 are important numbers. 50 and 260 are part of a Pythagorean triple, all right? If you imagined this is a right triangle, if instead of having the diameter going like that, you actually have the diameter, if you turned it around, to have it be the diagonal of the, whatever you call it, to have the diameter of the sphere be the diagonal of the cylinder, remember, these actually hit, right? What does that give you? That gives you a Pythagorean right triangle. And now, if we know that the radius of that cylinder is 50, the base of that triangle is going to be 100. the diagonal, the hypotenuse, is going to be 260. All right, and that is a version of the Pythagorean triple 5, 12, 13. All right, you want to recognize your Pythagorean triples. The most common one is 3, 4, 5, right? But 5, 12, 13 is tested a lot, and and this is just a multiple of that, right? Because 5, 12, 13, a multiple of that, if we multiply it by 2, would be 10, 24, 26. So here we simply have 100, 260, 240. That gives us the height, right? So the volume of the cylinder then is going to be pi times 50 squared times 240. And that is really all you need to do, all right? They might potentially factor out a pi or something like that, but that's all you need, all right? It's a tough problem, but it would be a lot easier if you kind of recognized that, oh, wait a minute, they're giving me some clues within this word problem, this kind of this geometric word problem. If I knew that these were numbers in the Pythagorean triple, it would make it easier to recognize that I need to get a right triangle. All right. Okay, I think we will stop there. I will stick around for another, I don't know, probably anywhere between 5 and 15 minutes to see if anyone's any questions, any clarifications. So yeah, I'll be here for a little while. I will leave the board up for a little bit, and thank you for stopping by. I'll scroll out a little bit so that you can see more of the board without it being too small. Sure. Which one? You mean the one with the averages, or the one with the factors? The average one. Yeah, that's a tricky one. Okay, so here's 1 second. Okay, so they're giving us. Let's start again. They're giving us this information. The average is 10. All right. There are 5 numbers. So let me just go and grab it again. 1 second. More space. Okay, 1 second. Oops. Okay, so they're asking us for 2 values, right? Given given that we've got our 5 numbers, let's say, let's go 1, 2, 3, 4, and 5. We know that the total is 50. Okay, now they're asking us for 2 situations. They're saying, first of all, we want to figure out what's the largest possible value of the highest number. All right, so let's say, what's the largest possible maximum value? And what is the smallest possible max value? All right. So they're asking us for 2 things, and they want us to find the difference between those 2. Okay, the largest possible maximum value. Well, if you want to find the largest, you want to minimize everything else. All right. So if we're going to minimize everything else, well, what are the lowest? What do we know? It says they're distinct, they're positive, and they're integers. So if we're going to minimize everything else, the first number's got to be 1. But because they're distinct, we can't have any duplicates, right? So the second number would have to be 2. Third number would be 3. Fourth number would be 4. That gives us a total of 10 out of the 50, which means the maximum number would be 40. Okay, so the first number is going to be 40. So that's this one here. Now, let's try this again. If we're going to get the smallest possible maximum value, that means that we're going to need to maximize everything else. But there's we can't go all that far, right? So what's the least possible value of the greatest of the 5 integers? Well, okay, let's assume all the numbers were 10. That would give us an average of 10, right? Okay, but all the numbers are not 10. All the numbers are distinct, right? So they're going to have to all be different numbers. And we're looking to figure out the smallest possible maximum value. Okay, well, this can't be 10, right? Because that would be a duplicate. If the smallest one were 11, that would be a problem too, because we need to have either 10 or 11 there, which would be a duplicate. That's not allowable, right? Could be 12. If this were 12, that would mean that we could have 11 there, but to balance things out, this would need to be 9, and that would need to be an 8, right? And that will give us, because now we'll have 10, 9 plus 11 will give us 30, 8 plus 12 will give us 50. So 12 is the least possible top value that we can have, all right? While still avoiding duplicate values. So what they're asking us is, what's the difference between those two values? Would be 40 minus 12, which would equal 28. That help? Sure thing. Thank you for attending the class. Have a good day. I'm gonna leave this up for another minute or two, and then I'm going to shut this thing off. All right, let's stop recording.